Today we get to look at the angle properties of a circle. Thanks for tuning in. Now there are various angle properties of a circle that are required to be held to memory, because when we are dealing with numbers that are involved with trying to find angles that are missing within circles, you interpret such questions using the properties. Let's look at the first property here. We have angles that are subtended at the circumference. Now these are the angles we are talking about that are being subtended at the circumference. You find that this angle Z is subtending this angle Z to the circumference. This angle Y is subtended to the circumference by this same chord. Then also this same chord subtends the angle X to the circumference. And we are saying that angles that are subtended to the circumference by the same chord are equal. So in this case, the value of X, Y, and Z, all these angles are equal. For example, if you look at this number here, we have angles X and we have angles Y, and we are required to what is the value of X and Y. But if you look at it here, we are having a chord passing through here. This chord is subtending that angle Y. It is the same chord subtending the angle 32. It's the same chord subtending the angle X. And since from that property that the angle subtended by the same chord to the circumference, all those angles are the same, it means that the value of X is also 32 and the value of Y is also 32. So X and Y, they are each 32. Getting to this here, we're required to find the values of A and B. If you look at this angle A, it is subtended by this chord. This chord subtends that angle to the circumference. Likewise, this same chord, it is subtending another angle to the circumference. So meaning that if this is 40 degrees, this is also 40 degrees, looking at the property we just looked at. It's the same with angle B. If you look at this angle B, it is subtended to this circumference by that chord, like that. And this same chord subtends another angle to the circumference. So if this angle is 25 degrees, it means that B is also 25 degrees. An angle that is subtended at the circumference by the diameter is equal to 90 degrees. Remember, when we were introducing chords earlier, we said that the diameter is the longest chord. And this is the longest chord that passing through the center of the circle. It is the diameter. So any angle that is subtended by the diameter to the circumference is 90. Subtended by the diameter to the circumference is 90. So meaning even if I had drawn another angle subtended to this diameter like that, this is 90 degrees, or another subtended by the same chord, this is still 90 degrees. In this next property, we are looking at an angle subtended by the same chord. One angle is subtended to the center, and the other angle is subtended to the circumference. And we are saying that if we are having an angle that is subtended to the center, if the angle subtended to the center is 2x, so it means that the angle that is subtended by the same chord to the circumference is going to be a half of that. Just like we are seeing a chord here, it is subtending a certain angle to the center, and this same chord, it is subtending this same chord is subtending another angle to the circumference. So it means that if this angle that is subtended to the circumference is y, then it means the one that is subtended to the center is twice that one, just like we've seen here. So the property is simple, that an angle subtended by an arc or a chord at the center is twice the angle subtended at the circumference by the same arc or chord. Let's do some examples to illustrate this. If you look at this, for example, we have 24 degrees there, and we are required to find the value of A. Now the value of A here is going to be, we remember that this is the same chord, it is subtending 24 degrees to the circumference, it's subtending the same another angle at the center. So meaning that this angle is going to be twice that one. So the value of A here is going to be 2 times 24, and it will be 48 degrees. Same here. The value of x here is going to be 2 times 70, and that is going to be 140 degrees, using the property we have just talked about. We need to find the value of y, but we see that we are having the same chord here. It is subtending 30 degrees there, and the same chord is subtending an angle y at the circumference. We know that this is twice that by the property we just saw. So it means that to get the value of y is going to give us 130 degrees, divide that by 2. And so our answer is going to be 6, 5. If you look at this circle, we're having an angle 60 degrees here, and we're having an angle x there. We need to find this angle x. But you realize that it is all subtended by the same chord. We have this chord. This chord, you see, is subtending an angle at the center, and the same chord is subtending another angle to the circumference. So we know that this angle here is twice that one by the property we just saw. So it means the value of x here is going to be 60 times 2. So our value of x there is going to be equal to 60 times 2, and so the answer is 120 degrees. Cyclic quadrilaterals. A cyclic quadrilateral is simply an image. It's simply one which has all its 4 vertices at the circumference. So if you look at this, it's having its vertices all touching the circumference of a circle. When you're having an object whose vertices are touching all the circumference of a circle, then that qualifies to be a cyclic quadrilateral. The condition is that those vertices must touch the circumference of the circle. And opposite angles in a cyclic quadrilateral add up to 180 degrees. So meaning that y plus z is equal to 180 degrees, x plus r is equal to 180 degrees. As simple as that. Looking at some examples to illustrate this point, we need to find the value of a. But this is a cyclic quadrilateral because all its 4 vertices are touching the circumference of the circle. So it means that the value of a here is going to be equal to this plus that is 180 degrees. So it means to get the value of a is going to be 180 degrees minus 118. And our value of a will be 62 degrees. Likewise here, we have a cyclic quadrilateral. Its vertices are all touching the circle's circumference. So to get the value of x, we know that the opposite angles of a cyclic quadrilateral add up to 180 degrees. So x plus 65 is equal to 180 degrees. So meaning our value of x is going to be 180 degrees minus 65. And our answer will be 115 degrees as our answer. So likewise, looking at this other cyclic quadrilateral, y plus 115 degrees is supposed to be equal to 180 degrees. So we shall still say y plus 115 degrees is equal to 180 degrees. Y will be 180 degrees minus 115 degrees. So we shall end up with our value of y as 65 degrees. If one side of a cyclic quadrilateral is produced, the external angle formed is equal to the opposite interior angle. This is one of the sides that has been produced, so it means that this exterior angle should be equal to the interior angle there. Likewise, if I produce this line, it means that if this is my angle y, it means that it's supposed to be equal to the opposite interior angle, which is that y. In the same way, if I produced this line like that, and this is my value of z, that is the angle. So if this line is produced and that's value of z, that's the angle, the exterior angle, this exterior angle is equal to the opposite interior angle, which is that. So that is one of the properties, that's the last property. We call it the alternate segment theorem. Now, before, remember we said that when a chord divides a circle into two, a chord divides a circle into what we call segments. We have what we call the major segment and the minor segment. Now, here we are looking at the alternate segment theorem, and it simply states that if a chord is drawn with one end at the point of contact with a tangent, this is the chord we are talking about. If one end of the chord is at the point of contact with this tangent to the circle, the angle between the chord and the tangent, the angle between this chord and the tangent, which in this case is x, is equal to the angle in the alternate segment. So this is the chord we are talking about. When you look at this chord, it divides this circle into this segment and the other segment. So it means that if this is the segment within which the angle x is, it means the alternate segment is this other one. And the angle that is in this other alternate segment is equal to that angle. This is called the alternate segment theorem. By alternate segment, to make it clearer, this is what I mean. If you look at this chord, it is dividing this circle into the major segment and the minor segment. If you look at this circle, this chord divides in the circle into the major segment and the minor segment. So if the angle is located between the tangent, between this tangent and the chord, if that's the angle x, it means the alternate segment we are talking about is the shaded region. Likewise here, the alternate segment is the shaded region, because in this other segment, that is where the angle is, and this is the angle that is between the chord and the tangent. If you look at this value of x, this is the angle x. The angle in the alternate segment is that one. Likewise, this is another chord dividing that segment and this segment. So if the angle is between the tangent and the chord, which is y, it means the other angle in the alternate segment will be that one. This brings us to the end of this video. Thank you for watching. For more videos, I encourage you to subscribe to this channel and also to share on other platforms. I hope you watch the next video. For Kisembo Academy, this is Arnold Rangakuramia.